Today we are going to learn about how to find the eigenvalues and eigenvectors. Eigenvalues and eigenvectors. First, only two steps we are having in this one. The first step, characteristic equation we are going to find, that is mod a minus lambda I, which is equals to 0. Right. Next, after solving this one, determinant of a minus lambda I, we are going to get one polynomial equation. Polynomial equation in terms of lambda. When we are going to solve this polynomial equation, we are going to get lambda values. These lambda values are known as eigenvectors. This is known as eigenvectors. Then after that we are going to proceed for second step for finding the eigenvectors. A matrix A minus lambda I into X, which is equals to 0. This will take it as a I, because whatever the order is going to be there, those many eigenvalues we are going to get. For those many eigenvalues, we have to find the eigenvectors. So this will give you eigenvectors. I will take the problem for find eigenvalues and eigenvectors of matrix A, which is equals to 4, 2, 1, 3. First, we'll find the characteristic equation. Characteristic equation mod of A minus lambda I, which is equals to 0. Then mod of, what is the matrix? 4 minus lambda, 2, then 1, 3 minus lambda, which is equals to 0. What we are going to get from here? 4 minus lambda into 3 minus lambda. 4 minus lambda into 3 minus lambda minus 2, which is equals to 0. Now find 4 into 3. It's equals to 12 minus 4 lambda minus 3 lambda plus lambda square minus 2 is equals to 0. Lambda square minus 7 lambda plus 10, which is equals to 0. This is known as characteristic equation. Characteristic equation. Characteristic equation. Now for this one, 7 lambda and constant here 10 I am having. So this 7 I can split into 5 and 2. So how I am going to write? Lambda square minus 5 lambda minus 2 lambda plus 10, which is equals to 0. From these two terms, I can take lambda as common. Lambda of lambda minus 5, and from these two terms, I can take minus 2 as common. Minus 2 of lambda, then minus 5, it's equals to 0. From this completely, I can take which term as common? 5 minus lambda as common. This method is known as common factors. Lambda minus 5, then into lambda minus 2, it's equals to 0. Lambda minus 5, which is equals to 0, or lambda minus 2, it's equals to 0. Lambda is equals to 5 or lambda is equals to 2. Therefore, lambda is equals to 2 comma 5. This is known as eigenvalues. Eigenvalues. After getting that eigenvalues, we'll proceed for the second step for finding the eigenvectors. How we'll proceed for finding the eigenvectors? First case 1, lambda 1, which is equals to 2. That is matrix of A minus lambda I into x, it's equals to 0, which is equals to 4 minus lambda, and then 4 minus lambda, 2, 1, 3 minus lambda, and x is equals to x1, x2, which is equals to 0. Now substitute this lambda value. Lambda value is equals to what? Your 2 is your lambda value. So 4 minus 2, 2, 1, 3 minus 2 into x1, x2, which is equals to 0. Now 4 minus 2, it's equals to how much? It's equals to 2, then this is 2, 1, 3 minus 2, it's equals to 1, x1, x2, which is equals to 0. What matrices we got? It's equals to 2, 2, 1 and 1. x1, x2, which is equals to 0. Now we can reduce this into the echelon form, or you can go by statistical method. But when you are applying the statistical method, you have to see that the two equations which you are going to take, it should not be identical same. So here I am going to apply that echelon form. I am going to make this element is equals to 0, and remember vector should not come as an equals to 0. So that operation for making this is equals to 0, what operation you are going to write? R2, that is known as in the computer language, it's a coding. R2 tends to R2 minus. So here in R1 I am having 2. So here 1 is there. So I will multiply that R2 with the 2 minus R1, which is equals to 2, 2, 0, 0, x1, x2, which is equals to 0. Now write it in the equation form. 2x1, what is the rank? Rank of A, it's equals to 1, where your solution will decide how many arbitrary constants you are going to assign to the variables. That is equals to number of unknowns minus rank of A, and this the system possesses non-trivial solution. The system, otherwise I'll write in the next one. The system possesses non-trivial solution. Right. Now write it into the equation form. Your matrix, write it into the equation form. 2x1 plus, which is equals to, now I will assign constant, that is x1 plus 2x2, it's equals to 0. So I will take let x2, it's equals to some arbitrary constant k. So when I am going to substitute in this equation, what I am going to get? 2x1 plus 2x1 plus 2k, it's equals to 0. 2x1, it's equals to minus 2k. When I am sending this 2k on this side, it will become minus. So this and this will get cancelled. x1, it's equals to minus k. So now your first vector, this is your x1, one value, and where we have assigned that is equals to your x2 value, that first vector x1 and x2, which is equals to minus k and k, which is equals to k. If I am going to take as common, then it going to be minus 1 and 1. This is known as eigenvectors. This is known as eigenvector. This is the eigenvectors for the first case when lambda is equals to when lambda is equals to 2. Now in the similar way we have to find for lambda is equals to 5. For next case, your case 2, when lambda 2 it's equals to 5, matrix A minus lambda I into x2 it's equals to 0. So 4 minus lambda 2 1, 3 minus lambda into x1 x2, which is equals to 0. Now what is here lambda value? Here lambda value is equals to 5, that we have to substitute here, which is equals to 4 minus 5 2 1, 3 minus 5 x1 x2, which is equals to 0. So what I am going to get here, 4 minus 5 it's equals to minus 1, then 2 1, next is equals to what, 3 minus 5 it's equals to minus 2, x1 x2 it's equals to 0. Now again here again I am applying echelon form. In echelon form you have to make your lower triangle is equals to 0. According to the echelon form, second row should consist of a single 0. As rows increases, number of zeros will increases. So I have to make this element is equals to 0. So now how I am going to write into the coding form, that R2 tends to R2 already 1 R1 it's a minus 1 is there. If I am going to add them, it will become 0. So R2 plus R1. So what I am going to get, minus 1 2 1 plus 1 it's equals to 0, minus 2 plus 2 it's equals to 0, x1 x2 which is equals to 0, where rank of A it's equals to 1. Rank of A is equals to 1. The system possess non-trivial solution. When we are finding the factor eigenvectors, the vector should come under non-trivial solution. It should not go for trivial solution. Trivial solution means completely the solution is going to be 0. It should not be equals to 0. At least vector should have one element. So your solution it's equals to number of unknowns minus rank of A. Number of unknowns is equals to 2, rank is equals to 1, it's equals to 1. So we are going to get one solution. So what the equation, what we got, that equation it's equals to minus x1 plus 2x2 which is equals to 0. Make this is equals to second equation. So now I will assign any one of the variable you are going to assign it's equals to some arbitrary constant. So let x2 it's equals to k. Substitute into the equation number 2. Substitute in equation 2. So minus x1 plus 2k it's equals to 0. x1 it's equals to 2k. So your second vector x2 which is equals to x1 x2 value is equals to 2k, and x2 we have assigned it's equals to k. So we will take k as common, 2 and 1. This is the second eigenvector. This is known as eigenvector. eigenvector for second case. So in this way we are going to find the eigenvalues and eigenvectors. If you are having any doubt, leave the comment in the comment box. In next class I will clear. Thank you.